For a rotation, it's like when you turn a shape. So for example, if you have a shape like this and you like just turn it like this way, or you turn it this way, so the direction and the orientation of it changes, but what stays the same is it's still the exact same shape. Like all the dimensions are the same, all the side lengths are the same, all the angles are the same. It's congruent to the original, it's just like turned in a new location. The coordinate rules we'll get to in a little bit, but we're going to focus on the concept first, as we usually do. So rotation is a turn. When you rotate about a center of rotation, and we'll get to that in a second. And also when you rotate, you can either rotate clockwise or counterclockwise. I know we don't use like analog clocks very much anymore, but the whole idea is if you're rotating this way, clockwise, that is a negative rotation. So like negative symbol. So all the way around clockwise would be like a negative 360-degree rotation. And then counterclockwise is a positive rotation. Positive. So if you're rotating this way, it's positive. So that would be like a positive 360-degree rotation if you go all the way around. So the rotations we focus on are 90, 180, and 270. So like 90 would be 1/4 of the way around, 180 would be like halfway to the halfway point, and 270 would be like 3/4 of the way around, just FYI. Okay, and then this portion right here, again, just building concepts. It says all points on the image must be equidistant or equidistant, however you want to say it, equidistant from the center of rotation as the points on the pre-image. And I'll explain what that means in a second, pre-image. Okay, so in this picture right here, this dot right here is going to be the center of rotation. So this is what the shape is rotating around. So for example, if we do a positive 90-degree rotation, if we rotate this shape positive 90 degrees, this distance right here from the center of rotation to the shape has to be the same over here. So like rotate it positive 90 degrees this way, and then we actually rotate points just like we do with translation or reflection. Essentially, we're rotating each point to the new location. And so this would be a 90-degree rotation, and then this angle should be 90 degrees. So if you connect the dot to the center to a corresponding point on each, this length should be the same, and then it should make 90 degrees for a 90-degree rotation. A negative 90-degree rotation would be this way, so negative 90-degree rotation. And again, the shape is the same distance from the center of rotation, just over here. And again, 90 degrees right here. Okay, and then moving down here, I have these drawn here, so you might want to sketch those out. So this is the original, and then it wants to just show you visually how the different rotations look. The center of rotation is generally the origin of the graph. So here to here would be a positive 90-degree rotation. And the whole concept is too, like if you have a corresponding point, so this point right here corresponds to this corner right here. And if we draw a straight line from this point to the origin, and draw a straight line from this point to the corresponding point, if it's a 90-degree rotation, we should get a 90-degree angle here. And then also these segments should be the same length. And then if you were like on a test or something and you just wanted to check it, you could use the corner of like a reference sheet and just see if it makes a 90-degree angle. And then this length right here should be the same as this. And you could use your paper to like measure and just make sure that that point's in the right location. Okay, the next one we're going to look at is 180-degree rotation. 180 degree would be like 2 turns, 2 turns to put it here. And again, if you choose a corresponding point, so this like elbow joint to this one, and connect the dots through the center of rotation, for 180-degree rotation, you should get 180-degree angle. So this would be 180 degrees. And then the next one is a 270-degree rotation. That would be this one. And again, you can draw a line from this corresponding point to the origin, and it should make a 270-degree angle here. So it would be from here, 270 degrees. And then also, just to make you aware, a positive 270-degree rotation would be the same as a negative 90-degree rotation. So positive 270 would be the same as negative 90. Or also, like a positive 90-degree rotation would be the same as a negative 270-degree rotation the other direction. And then 360-degree rotation would just put the shape on itself. And then when you're done with that, we're going to flip to the next page. Okay, so now we're going to look at the rotations just one at a time. Here it's saying 90 degrees counterclockwise rotation or negative 270 degrees clockwise. That would be the same thing. So we're going to rotate this shape 90 degrees counterclockwise. So like one turn this way. I did this exercise with the last couple classes. It's kind of interesting how it turned out. Can you rotate this shape on your own without me like explaining it? Can you rotate this shape 90 degrees and draw it in the correct orientation and everything over in this box? Try it out, kind of see if your brain can do this. Every brain's a little bit different when it comes to spatial reasoning. So try it out. Like with a pencil, of course, if you need to erase, but you're rotating this 90 degrees about the origin and drawing it over here. Okay, so if you drew the shape like this, you got it right. It'd be like this. So a 90-degree turn about the origin would look like this. And yes, then you can check yourself, just choose a corresponding point, this and this, draw a line to the origin, and it should make a 90-degree angle. So this here, 90-degree turn. It's also a negative 270-degree turn in the other direction. So that's visually how to do it. We'll get to the coordinates at the bottom of the page. For right now, I just want you to write down the rule. XY becomes negative YX, and we'll practice that in a few minutes. Okay, for the next one, 180 degrees counterclockwise or negative 180 degrees clockwise. So that would be like 2 turns. So you do 1, 2, put it over here. And what it would come out to, it would look like this. Like that. And that would be 180-degree rotation. Or a negative 180-degree rotation, same thing. And again, you can take a corresponding point, this point and this point, draw a line to the origin from both, and you should get a 180-degree angle right there, which is what we got. And then the rule for the coordinates, which again we'll get to later, is this, negative x, negative y. Okay, and then the next one, 270 degrees counterclockwise or negative 90 degrees clockwise. So that would be like 3 turns. So it's going to land over here. And the orientation for this shape would look like this. And so this would be positive 270 degrees, or also negative 90 degrees. Same thing. And it lands right here. And again, you can check your work just by choosing corresponding point, drawing a line to the origin, and this should make 270 degrees here or negative 90 degrees this way. And then the rule for the coordinates will be y negative x, but we'll get to that in a few minutes. Okay, so here it says, remember rotating counterclockwise when rotating positive degrees, and rotate clockwise when rotating negative degrees. Okay, so down here is where we kind of bring it all together, bring in the shapes. It says graph the figure in its image under the given rotation. It says rotate the figure 90 degrees counterclockwise. So that would be a positive 90-degree rotation. And then the coordinate rules for that would be xy becomes negative yx. And so that's not on a reference sheet or anything. So this would have to be memorized, just so you know. And then in doing it, so like as you write this down, just kind of commit it to memory as you go. Okay, so 90-degree rotation, we're going to rotate this shape like one turn this way, so we kind of visualize it a little bit. And then what we're going to do is we're just going to use the rule to change the points. So point J, K, and L, I'm going to write the original points here. So J, K, and L. So J is at 1, 2, 3, negative 4, 1, 2, 3, 4, 5. Negative 4, negative 5. K is at negative 3, negative 1. And then L is at negative 1, 1, 2, 3, 4. Negative 1, negative 4. And then from here, I'm going to use this rule to get J prime, K prime, and L prime. Okay, so the rule says negative yx. So essentially, this is going to change to the opposite sign. So anytime it says negative, you're just changing it the opposite sign. So this would be 5, and then x stays the same. A prime, let's see. So positive 1, and then x stays the same. And here, positive 4, and x stays the same. And then using these new points, I'm going to graph the rotated shape. And then just make sure it's logical. And to me it is. If you rotated this 90 degrees, that makes sense. Next one. Okay, for the next one, it says rotate the figure 180 degrees. So rotating this figure 2 turns, it'll land over in this quadrant over here. A positive 180-degree turn. The rule is xy becomes negative x, negative y. This to me is the easiest one for me to memorize. And so just like with the last one, I'm going to write all the original points, L, M, N, O. I'm going to write down the coordinates of those points. So L is at 1, 3. M is at 1, 2, 3, 3, 3. N is at 4, 0. And O is at 2, 0. And then I'm going to get L prime, M prime, N prime, and O prime. And so using the rule, it just says like opposite sign for x and y. So I can just rewrite it with negative symbols. So -1, -3, -3, -3, -4. 0 can't be negative, so it just stays 0. -2, 0. And now that I have the new points, I can graph it. Okay, are you ready for the next one? Are we bored? Okay, next one. Some people think I go too fast, and then other people think I go too slow, and then they get bored. Okay, this one here, ABC, 270-degree rotation. They didn't graph the original for us, so we'll go ahead and put it on the graph. Point A is at -3, 5. A. B is at 0, 2. And C, -5, 1. That's our original. And then a 270-degree rotation would be like 3 turns, so it's going to end up in this quadrant over here. And so for a positive 270-degree rotation, x, y becomes y, -x. You have to memorize it. It's not on the reference sheet. So the other way, like, you can, I don't know, figure it out if you forgot the rules would be like through the angles that I was showing you. You could figure it out that way. Okay, so the rule here, and then we have our originals, A, B, and C, and then we'll get our A prime, B prime, and C prime. And so y goes here in this spot, and then x changes sign. So y goes here, x changes sign, but 0 just stays the same. Y goes here, x changes sign. Okay, so A prime is at 5, 3. Do a new sheet. So, and then you could check yourself just by drawing lines to corresponding points to the origin. So if you draw a line from B to the origin and then B prime, you get this 90-degree angle, which makes sense because 270 degrees would be the same as -90, or you could do the same thing A to A prime, and it should give you a 90-degree angle each time. Okay, and then these two are just like little practice problems. It says if 0.52 is rotated clockwise, pause. If 0.52 is rotated counterclockwise 90 degrees, so that'd be positive 90 degrees, about the origin, its image will be what point? So positive 90 would be xy becomes negative yx. So 5, 2 would become -2. Oh, thank you. 5. Be this one. And C, how does the spinner appear after a 270 degrees clockwise rotation about point P? Okay, well, 90-degree spin would put it here. 180, it would be facing this way. And then 270 would be facing it this way. So it would be B. Then one more thing that's on in the answer bank is called magnitude of rotation. Magnitude of rotation. And what this is asking is if you have like a pentagon, let's say a regular pentagon where all the sides are the same length, all the angles are the same measure, like it's perfect. If you rotated it about the center of rotation, how many degrees would you need to rotate it for it to like land on itself? So if you rotated it one turn, it'd land on itself, but how many degrees is that? The way you'd figure that out is take 360 degrees, which is all the way around, divide by 5 by the 5 sides, and the magnitude of rotation is 72 degrees. Or like if you have a square, you could take 360, divide by 4, and the magnitude of rotation is 90 degrees. That's the turn you would need to rotate it onto itself again. Okay, that's all. So you have the last 18 minutes to get your homework done. Grab a laptop and get logged on. Once you're done, I see you. Okay, once you're done, make sure to log on to Alex and get that done as well. And yes, Lucas, you can go to the restroom. Okay.